you're going to play with heat, you might get burned.
You're funny, mister.
Looking. Funny looking.
Funny looking.
Measuring in heat calorimetry.
Video 5, yeah.
We're going to track how much heat is involved in changes in temperature and phase changes. So we're going to go through the notes quick because we want to spend time doing the calculations for you so that you have a good example to follow.
There you go. So the measure of heat stored is what we call calorimetry, and calorimeter is what we use to measure that.
Every food item in America has calories listed on it.
Literally,
they do this process using a calorimeter to figure out how much heat energy is in your food.
It was in your bell work today, actually. Table T is going to help give us those equations, and there's 3 of them
packaged in there. So we call this one CumaCat. We only use this one temperatures changing. That's the delta T.
Right, and we're going to apply that later to our heating and cooling curves. Where is the temperature changing? We'll know where to use that equation.
And then there's 2 others, CumaHIF and CumaHIV.
Yeah.
So the
I call it H sub F and H sub V, but however you want to do it.
Right.
The F is for freezing or fusion. It's really for fusion, but at the freezing point, it helps us get that, right?
Yeah, so you know to use that one when it's freezing. And vaporization, that's when it's boiling or condensing or vaporizing.
There you go.
So you use that equation then.
There you go. Low reading comp.
These values we find on reference table B.
Front page. This is where it gets tricky.
Because you're going to go front to back.
Yeah.
They put them on the front and the back so you can switch quickly and easily, but hey.
What's nice, though, is that the C tells you what it is, and then you go to table B and find out it has a value.
And that's what it is.
So you write that down.
Let's show that next one, too.
H sub F has a value, which is not nearly as high as
H sub V, which means that it takes less energy to melt water than it does to boil it.
And that makes sense because the molecules are much closer when they go from solid to liquid versus solid or liquid to gas. They're much farther apart.
It takes a lot of energy to boil water.
Yeah.
So we're going to sketch a heating curve and show you where to put the equations. Like if you're going to have to do a heating vaporization heat calculation, then Q means heat, it's during the higher flat part. And the lower flat part is when you'd use the fusion one.
Right. And then all the rest of them, the temperature's changing on the slants. This is 3. I'm going to go. That's 3. Toughest sign to learn. 3. Okay. So MCAT goes in all these spots if you happen to be there on the graph.
For sure. So this requires you to read your problem, figure out where you are to decide what equation to use.
Right. So real quick, you're going to find out, is the temperature changing, or are you finding one of those transition words, melting?
Right.
Right. Phase change words.
Phase changes, you use the simpler equation. When there's a temperature change, you use the one that has the delta T in it.
Correct.
So there it is. I mean, that's really all you need to know.
Yeah, that triangle delta does mean, or that triangle means delta, which means change in.
Yes.
And one of the things that we talked about in our bell work today, real quick, this is where I don't have to convert Kelvin into Celsius.
Because the units are the same size.
They're the same size, so the change actually comes out to be the same value.
Yeah, I'll probably do a bell work on that soon enough.
Yeah.
Okay. So, example heat flow calculations. This requires basic algebra.
Yep. You're at the board.
I'm at the board?
You're at the board.
Excellent. So
you like to rewrite all the equations.
I want you to write the equation. My students make mistakes when they don't.
Right. So I'm going to read this real quick. It says how much heat is absorbed. So I'm looking for heat. When I have 100 grams of water that's heated from 20 degrees to 75 degrees. Now, if this wasn't in the notes where it was under MCAT, I'd be looking to see that the temperature was 20 degrees and then it went to 75 degrees. So hence change in temperature. I need to be able to pull that out to decode that is the change in temperature. So I need to use the change in temperature equation. Now I'm just plugging and chugging. I got 100 grams from the problem. C is a constant, 4.18. My change in temperature goes from 20 to 75. So it's a 55 degree change in temperature. Plug and chug. We're not going to do the answer. I'm going to leave that for you guys to calculate. Put a big box there if you want.
If we ignore the units, it's just multiplication.
True. And the gram or the grams cancel, the Celsius cancels, leaves me in joules. Very good.
Very good.
Very good. I can ask you about a different part of that equation. Okay. We can give you the amount of heat and the mass and say, ooh, what would the final temperature be? This is a 2-step problem. Okay, because now I'm going to solve for delta T because I got Q is 1,000. I got my mass is 100. I know my C. I don't have to look that up. That's a given, right? I don't have to look that up. I'm dealing with water. I'm going to straight solve for delta T now. Okay, and delta T is going to be a number. Let's pretend that should we finish it out or actually calculate this one all the way out so we can finish it?
Well,
this one's tough.
The change in temperature, we're going to know. It's going to change by some degrees. This is just algebra. You solve for delta T, and then you look back to the problem and see that, well, if you started at 25 degrees and you know the temperature changed by, let's imagine it's 50,
okay,
well, then it means that it
ended at 75.
There you go. So
that is the second part, though.
Yeah.
So we're going to get a number for delta T.
Temp.
And
so your answer is going to be some degrees Celsius.
Right.
So add your starting temperature to your delta T, and you've got your final answer.
Okay, good.
Okay, let's keep going.
Okay. How much heat is used to melt? So right off the bat, melt is H sub F. So we need to put in the right equation because that is going to be a different value. And this one's a little bit easier because it's just grams is 50 times 334, which is my H sub F. You tell me what the answer is, you got to calculate. Right.
Boom.
Good. Moving on because we're going to try and make this
next
quick. So now it's how much heat is used to freeze a sample. So I got a 60-gram sample and I'm freezing. Freezing starts with F, so again, H sub F. That's how it helps, right? So I know I'm just going to plug in my grams. I got Q equals 60 grams times 334. And Mr. Monaco will throw those units in for us, and you will plug and chug this out of your calculator. Okay?
Yep.
Groovy. Good? Good. Moving on. I'm guessing we're going to go H sub V. Now I see vaporize. How much energy is absorbed to vaporize? H sub V. Okay, now I just got a different constant. I still got 19 grams goes in for my mass. Now it's what, 2,230?
2260.
2260, that's it. I got my 34s.
Let me look at my reference tables.
2260.
Nice. Going to be a bigger number.
Yep.
Yep. One more, and we're done.
One more, and we're done.
What kind of done?
Nice job.
You good. You good.
Okay.
All right, 70 gram sample. Vapor is condensed, but vapor is condensed. So I'm just cooling, but I'm still at that same point. So it's still H sub V, vapor. Key letter there. So I'm going to use the other constant, H sub V, multiply it times my mass, and again, I will get an answer. So that isn't so hard either. These are easier than the MCAT just because there's less variables. For sure. Right?
Mm-hmm.
Okay, good. Deep breath. Okay, good. And
That's it?
That's it. Whoops. That's it. So you do have a lot of practice pages on this. So there is that piece of the reading comprehension that is so important. What stage of the game am I at? You got to know.
Right. And I want to point out the fact that these calculations are related to the heating of the water. So heat is flowing into and out of the water in these problems. If it's being heated up, well, the heat's flowing in. If it's being cooled down, the heat's flowing out. And all we were doing there was calculating how much heat was involved in that change.
Right.
And there was the one example where we were given the amount of heat and we had to figure the change in temperature, which is that second level problem.
Kind of, yeah. But
For
it
sure.
really is the same thing because it's plug and chug.
And if we do it the way that we showed there by solving for delta T and then adding your original starting temperature,
That is the real
That's
second
it.
level problem.
That's
That one's
all there
got
is
the
to it.
second step. So it's a little tougher, but I think you guys can do it. We'll do one in class to make sure you know how to do it.
I think you should watch this video twice because we went through those calculations very quickly and I want to see you do the answers. We put left blocks,
Yeah.
put blanks.
Does it go without saying anymore? If you have blocks on your homework, that's not complete. You need to finish it. See you guys.
Oh, let me see what's going on here. Let me
Listen, you're so corny.
turn off this there.